All right, welcome to The Explainer. Today we're going to talk about something you've probably seen a million times, but maybe never really thought about. It's a hidden architectural marvel, and odds are it's sitting in your kitchen right now. So, let me ask you something. Have you ever sliced open a tomato and just paused for a second? You see that star-like pattern inside, right? The way the seeds are all arranged so perfectly? Well, guess what? That is not random. Not at all. It's a design, a secret blueprint hiding in plain sight.
And yeah, that pattern, it actually has a name. It's called placentation. And really, it's just the plant's architectural plan for its future seeds. You could say it's the blueprint for building the next generation.
And here's where it gets really interesting. Plants are, well, they're creative. They don't just have one way of doing this. Nope. They have come up with 5 main design blueprints. 5! And each one is a totally different strategy for survival and reproduction.
Okay, so let's circle back and solve our tomato puzzle. That pattern you see when you slice one open, that's our very first design, and it's one of the most common ones out there. This design, the one you see in tomatoes, but also in things like lemons and kiwis, is called axial placentation. And if you think axis, you're on the right track, because that's exactly what it is. Everything is built around a central point.
So here's how it works. You've got that central column, and that's where the future seeds attach. But, and this is the key part, the whole thing is divided up by these little walls. You know, like the segments in an orange? Those walls create separate rooms or chambers. It's an incredibly organized and sturdy setup.
But hey, that's just one of the 5 blueprints. We've still got 4 more to go. So let's check out the other incredible ways that plants organize their future. Okay, next up is a design that is just super simple. I mean, honestly, it's basically like a zipper. This one's called marginal plantation.
You definitely know what this looks like. Just picture a pea pod. You snap it open, and all the peas are lined up perfectly in a row, right along one edge, the margin. It's all happening inside one single chamber. So simple, so efficient.
So what if instead of building from the center, you just attach the seeds to the outer walls? Well, that's exactly what some plants do. It's called parietal placentation. And the name makes perfect sense. Parietal comes from the Latin word for wall.
So there's no central column here at all. The seeds are attached right to the perimeter, the inside of the ovary walls. You see this in plants like mustard. Now, it's usually just one big chamber, but sometimes a sort of false wall can form, which kind of makes it look like there are 2. But don't let that fool you. The main idea is that the seeds are growing from the outer wall.
All right, you're going to want to pay close attention to this next one because it's a little tricky. It looks a lot like our tomato example, but with one huge, game-changing difference. This is called free central placentation.
Okay, so you still have that central axis where the seeds are attached. But here's the twist. There are no dividing walls. None. The entire ovary is just one big open room. And that's why it's called free central. The column is just standing free in the middle, not connected to anything.
So let's just put these 2 side by side to make it crystal clear. Axial, our tomato or lemon, has a central post, and it has walls creating those separate rooms. But free, central, has the central post, but no walls. Just one big space. That single detail, walls or no walls, is the only difference, but it changes everything.
All right, we've seen some pretty complex setups. Our last blueprint, though, it's the complete opposite. It's the minimalist of the group. Pure, simple, elegant. It's called basal placentation.
And the name pretty much tells you everything you need to know. Basal just means base. The placenta develops right at the bottom of the ovary, and attached to it is usually just a single ovule. The perfect example? A sunflower seed. When you crack open the shell, that one seed inside was attached right at the very bottom. That's it. So clean, so simple.
Okay, so let's recap. We've got our 5 designs. On the edge, in the center with walls, on the outer walls, in the center with no walls, and at the base. But so what? Why are there so many? Why doesn't every plant just pick one design and stick with it? What's the big picture here?
Well, this is way more than just botanical trivia. This is about evolution. It's a direct reflection of the incredible, mind-boggling diversity of the plant kingdom. Each of these blueprints gives a plant a different set of advantages. Maybe for protecting its seeds, maybe for spreading them. It's a huge clue for botanists trying to identify a plant. And, for the rest of us, it just gives you a whole new appreciation for the clever architecture of the food we eat every single day.
So here is my challenge to you. The next time you're in the kitchen and you slice open a pepper, or a cucumber, or an apple, an orange, whatever it is, just stop. Take a second and look inside. What do you see? Can you spot the blueprint? Is it axile? Is it parietal? You are now officially a placentation detective. Go explore your own kitchen and see what you can find. I think you'll be surprised.